So, where were you yesterday? Where were we yesterday? Yesterday we were talking about this marginal stability of equilibria. So, we select one point or another point that is an equilibrium point, and we characterize the stability properties. Marginally stable if the game leads to you win, unstable if the boss wins. How does the game work? Let's repeat it. Who starts first? The boss or you? The boss, true? And the boss draws a certain epsilon neighborhood around your equilibrium. Let's start with this one. Let's say that the boss says, are you able to confine the trajectory inside here? What do you have to do? You need to find a set of initial conditions. There is going to be a ball around the equilibrium, such that starting in that set of initial conditions, the trajectories will stay there, inside the outer. So we are going to have the epsilon that the boss draws, the delta that you draw, and you draw it so that starting in delta, anywhere in delta, guarantees you stay in epsilon. Okay? Mathematically speaking, what does it mean? It means that for any epsilon ball that the boss draws, you must be able to find there exists a delta ball that you can draw, and of course the radius has to be bigger than 0, such that if the initial condition belongs to this object here, then the trajectory belongs to this. Okay? Together? Perfect. Shall we try to play the game for this equilibrium point here? If I draw you this epsilon ball, are you going to be able to find a delta ball such that starting in the delta ball will guarantee you staying in that epsilon ball? No. True? It's a situation that is similar to this one. True? You see that in a situation that is like this one, whenever the boss draws this stuff here, you can't find any delta ball such that for all the points inside the delta ball, you stay inside the epsilon ball. Because every delta ball that you draw is going to be having some that go away. Away from epsilon, not away from delta. How much are we together, people? 1, 2, 3. Perfect. And this one is, if the boss is okay, you might be able to win that specific epsilon. But if the boss selects this one, you can't. Okay? Since there exist situations for which the boss selects something for which you lose. And it's unstable. Okay? Together? Let's go here. Do we see, from looking at the phase portrait, that that one is marginally stable? Do you see? The one in the center here, this one here, this equilibrium, that is marginally stable, okay? Simply stable. This one, I think you already did it. People, what would you say? You would say 2, true? The epsilon ball, the bigger ball. Can the delta ball be bigger than the epsilon ball? Yes, no, I do not know. Discuss. This is the one that you draw, this is the boss draws. So it's like yes, no, I do not know. So what would you say? No, why? Because if this is my delta and this is my epsilon, if I start here, I'm already outside epsilon. Obvious, true. If I have a phase portrait for which the trajectories look like an ellipsoid, hmm, can I have delta equal to epsilon? Sorry. I decided to turn off. I do not know why. Don't ask me why. Is it going now? Try to turn it on again. Sorry, might have been some voltage drop. Are the monitors working now? So let's answer this and then we fix the stuff. If we have not round trajectories, can we have the two balls to be the same? No. Okay, are we together? See, the delta ball, if I draw these as epsilon ball, I must have these as delta ball. Because I've got something on the border that will go on the border. Got the point? Together? Perfect. Questions about marginal stability? No. And then